Hey folks, welcome to my channel Number Pen. So there we have the problem on our screen. If y equals e to the power tan inverse of x, show that 1 plus x square into y double dashed plus 2x minus 1 into y dashed equals 0, right? So our y is equal to e to the power tan inverse of x. So let's write that down. We've been asked to find y dashed and y double dashed and put it back in the expression which is shown to us. So I have a tan inverse of x, right? And might be a lot simpler if I make a substitution x equals tan theta, right? And I do that substitution, what happens to my e to the power tan inverse of x? It becomes e to the power tan inverse of tan theta, which is nothing but a theta, right? I'll write down the substitution here. My x equals tan theta, and therefore now my y equals e to the power theta, right? So now I'm going to work out my dy by dx using chain rule, right? My dy by dx is nothing but dy by d theta into d theta by dx, right? My dy by d theta is nothing but dy by d theta of e to the power theta. Let's highlight it in, say, green. And this green expression, dy by d theta, is nothing but, again, it's an e to the power theta, right? We know this from first principles, so let's write it as it is. And then my x equals tan theta means my dx by d theta, or let me call it d by dx of x equals 1. And on the RHS, I will have secant square theta into d theta by dx, right? So what happens to my d theta by dx? It is nothing but a 1 by secant square theta, which is nothing but a cos square theta, right? So let's write that down as well. So I have my dy by dx in terms of theta now, and I'm perfectly okay with that. And then I go ahead and do my d by dx of dy by dx. Why is that? Because we have a y double dashed in the expression which is given to us, which means I will have to work out my d by dx of dy by dx, right? I'm going to pick up the previous expression where we have dy by dx in terms of theta, and I'm going to apply the product rule of differentiation because we've got a product of two functions. Function 1 is e to the power theta, function 2 is cos square theta, right? So my function 1, when I differentiate it with respect to x, is nothing but e to the power theta. Again, I use the same green color, e to the power theta. But remember, folks, we are doing a differentiation with respect to x, right? So I need to go to the inner function and do a differentiation of theta with respect to x, which means I will have my d theta by dx out here, right? And then I have into my cos square x. I retain the function as it is, the second function. And then I go ahead, retain the first function as it is, which is again an e to the power theta, and I differentiate the second function with respect to x. So d by dx of cos square theta is nothing but I apply the chain rule first. So my 2 comes out, and then let me So my 2 comes out, and then I have a cos theta, 2 times cos theta, and then I go ahead and differentiate my inner function, which is cos theta. So d by dx of cos theta is nothing but a minus of sine theta. And then I will still have to differentiate my innermost theta with respect to x, which is nothing but again a d theta by dx. Right? So this is what I have, right? So let's rearrange this particular expression. So I have my y double dashed as well, right? Now it's in terms of d theta by dx, right? And where do I go for my d theta by dx? My d theta by dx is nothing but a cos square theta. And how do I get it? I get it from my previous step, right? Because I have x equals tan theta, I differentiate on either side. My d theta by dx becomes equal to 1 by secant square theta, which is nothing but a cos square theta, right? So let me go to the next step. A y double dashed is nothing but e to the power theta into d theta by dx is nothing but cos square theta, right? So we have a cos square theta into cos square theta, that makes it cos to the power 4 theta, into cos square theta, which is my d theta by dx, becomes 2 times e to the power theta into cos cube of theta sine theta. So let's pull out the expression which is given to us, and let's do the substitution of y double dashed and y dashed into this expression, right? Now I have my y dashed and y double dashed in terms of theta, which is perfectly fine, right? But I will have to replace my x in terms of theta, right? So my 1 plus x square is nothing but 1 plus tan square theta, which is nothing but a secant square theta, right? And then I have a y double dashed here, right? I just copy this as it is now. And then I have a 2 times tan theta minus 1. Why is that? Because my x is tan theta minus 1. And I copy my, so my u is equal to my secant square theta into cos to the power 4 theta, right? Means that I'm left with e to the power theta into cos square theta, right? With respect to the first part of the expression. Why is that? Because my secant square is nothing but 1 by cos square, right? Therefore, I can cancel out the cos square with the cos power 4 theta, and I'm left with e to the power theta minus, sorry, e to the power theta into cos square theta. And similarly, when I come to the second part of the expression, my secant square theta is 1 by cos square theta, which means I'm left with 2 times e to the power theta into a sine theta cos theta, right? 2 tan theta minus 1 into e to the power theta cos square theta, right? So let's pull out the e to the power theta first. My tan theta is nothing but sine theta by cos theta, right? So 2 tan theta becomes 2 times sine theta by cos theta into cos square theta, which means I can cancel out 1 cos theta of the cos square theta, right? So When I express my tan theta as sine theta by cos theta, I know that I can rewrite this particular expression as 2 times e to the power sine theta cos theta again, right? And then I come to my final part of the expression, which is I don't think I will have to do any simplification here, minus of 1 into e to the power cos square theta. So I write it like this. Now you see that I can comfortably tell that this equation is 0, right? Why is that? I have an e to the power cos square theta, which is this one. I can cancel it out with the minus e to the power theta cos square theta, which I've highlighted in yellow. And then this part is 2 to the power, 2 times sine theta cos theta into e to the power theta again gets cancelled out, which I've highlighted in green. And therefore, we know that this term equals 0, right? And that's what we've been asked to prove, right? There we are. So I hope you found this content useful. Please do subscribe to my channel and support. Thank you.